In this video, we're going to talk about the unit circle method to find the exact trigonometric function values. We're going to start with the basics and then we do 10 examples. We can use the unit circle to find trigonometric function values for a special class of values, which are multiples of 30, 45 or 60 degrees, or in radian, it is pi over 6, pi over 4 or pi over 3. After you learn the method, you can find the exact trigonometric function values for positive angles, negative angles, and then multiples of pi over 6, multiples of pi over 4, and multiples of pi over 3. Even like angles which are more than 360 degrees. So let's talk about the basics. The method works for a special class of angles that are multiples of 30, 45, 60 degrees, or in radian, pi over 6, pi over 4 or pi over 3. And we can talk about all four quadrants. So that means we can talk about angles in quadrant 1, and then angles in quadrant 2, angles in quadrant 3, and the angles in quadrant 4. So these are all the angles that are in all those four quadrants. So you can see that we have 30, 45, 60, and then on the other side we have 120, 135, 150, and on quadrant 3 we have 210, 225 and 240. In quadrant 4 we have 300, 315 and 330. So let's talk about how you get those numbers starting from those three special values. These are three special values. And then also we notice that if you pick any point on the unit circle, something special happen if you square the x coordinate, and then if you square the y coordinate, and you can see that it's going to add up to 1. So because these points lies on the unit circle. So let's talk about where we get those special angles. So we can talk about the two cases, first in degrees. So the degree values are so it is 30, start with 30, and then 45, and then 60 degrees. So the easiest one to work with is 45. So if it is 45, and then we can see that on angle on the second quadrant is 3 times 45, because we have 90, that is 2 times, 3 times, so that means it is 135 degrees. And then on the third quadrant it is 225, so which is more than 45 more than 180. So if you add 180 and 45 you get 225. And then on the fourth quadrant you can see that we have 360. So if you subtract 45 from 360 you get this angle. This is 315. So this is 360 minus 45. So those are the angles related to 45 degrees. And then similarly we can find the angles related to 30. So what we can do is we can subtract 30 from 180. So you get it's a different color, so you get 150 here. So these are the related to 30, and then if you add 30 to 180 you get 210, and then if you subtract 30 from 360 you get 330. So those are the angles related to 30 degrees. And then let's talk about the angles that are related to 60. So we have 60. So and on the other side you have 120. And if you add, so that means how you get 120? 120 means 180 minus 60. And then you have 180 plus 60. So that means 240. So this is how you get 180 plus 60. And then one on the fourth quadrant, which is 360 minus 60. So this is 300. So those are the special angles. Those are related to 30, 45 and 60 degrees. And these are the quadrants. So this is the first quadrant, and the second quadrant, and the third quadrant, and the fourth quadrant. We normally use Roman letters for that. So let's do what's going to happen with the radian now. For radian we also start with the three basic values, which is pi over 6, That's the smallest, and then pi over 4, and then pi over 3. So again we can do the pi over 4 ones first. Um, so what we have is, so if you subtract, because this is exactly in the middle, so we have pi and pi over 2, so if we add them and divide by 2, or the other way is you can subtract pi minus pi over 4, that means this is going to be 3 pi over 4, that's the angle on the second quadrant. On the third quadrant, and you can see that, so we have 3 pi over 4, so what we're going to do, so this is 5 pi over 4. So how you get it? You can add pi over 4 to pi, and then on the other side we have 7 pi over 4. So that is the angle on the fourth quadrant. So those are the angles, are multiples of pi over 4. Now we can do similarly angles of multiples of pi over 6. So subtracting pi over 6 from pi, we're gonna get 5 pi over 6 here. So we have 5 pi over 6, 5 pi over 6. And then, so if you add pi over 6, you get 7 pi over 6 here. And then if you subtract pi over 6 from 2 pi, so you get 11 pi over 6 here. So those are the multiples of pi over 6. And then we can do multiples of pi over 3. So we have pi over 3, and then if you subtract pi over 3 from pi, you're going to get 2 pi over 3. And on this side, so you're going to get, so it is pi plus pi over 3. So that means you get 4 pi over 3, 4 pi over 3. This is pi plus pi over 3. And on the other side, we have 5 pi over 3 on the other side. So those are the common values that are multiples of radian values. And then we also have the x and y coordinate of the corner points. So so we have these the values at 1 0 and 0 1, and then negative 1 0 and 0 negative 1. So those are the common values in degrees and radian. Now let's put everything together, and you can see that we have these all the values in the unit circle now. This has all the radian and degree values in one diagram. So this is what you need to remember. The only thing that we need to discuss is where you get those x and y coordinate and how to find the coordinate on the other three quadrant. So let's talk about that now. We can start with the first quadrant. Before we find the values, we're going to notice something. So if you pick any angle, for example, let's say we're going to pick angle 30. So we can draw a triangle. So this is the triangle for angle 30. So this is the x-axis. What we can do is we can drop a perpendicular. So this is angle 30. And then you can notice that if you look at the x-coordinate, since this side is simply 1, this x-coordinate is simply going to be cosine 30. So that's the x-coordinate. And then the y-coordinate is going to be sine 30. So this gonna work for all the angles. So that means the x-coordinate is the cosine value, y-coordinate is the sine value. Now we can use that idea here. So since we know the cosine and sine values for 30, 45 and 60 degrees, so so we first write the x-coordinate, which is the cosine value. So cosine 30, which is square root 3 over 2. And the sine 30, which is 1/2, that is the y value. So similarly, we know that the sine and cosine 45 are the same, which are square root of 1 over 2. So we can write those values here. So the cosine 45, which is the x-coordinate, sine 45, which is the y-coordinate. And similarly, for angle 60, cosine 60 is 1/2, and sine 60 is square root 3 over 2. So we write the x-coordinate first, and then the y-coordinate next. and the x coordinate is the cosine value, and the y coordinate is the sine value. Okay, so now we can find the other values in the other three quadrants using the symmetry argument. So let's see how we can do that next. So now we have values on the first quadrant, and the goal is to find the values on the other quadrant. So let's see how the argument works. So what we're gonna do, we're gonna look at the symmetry. So let's say we have the xy coordinate system. So we're gonna pick a random point. So let's say we have a point xy. So this is the point xy, x and y. Now what we're gonna do, we're gonna reflect this point across the y-axis. So if you reflect the point across the y-axis, what's gonna happen? It's gonna jump to the other side. So what are the coordinates of this point? And you can see that the x coordinate change the sign. So and then so it was here, and then it's jumped to the other side. It's going to be negative x. So x coordinate change the sign. Y coordinate did not change. So that means this one is simply negative x y. So that means if you know the xy point, we can simply find the point on the first quadrant, switching the changing the sign of the x coordinate and no change to the y coordinate. So this is the reflection across the y axis. Reflection across the y axis. So what will happen if you reflect across the x axis? Then what's going to happen? This point jump across the x axis. So you can see that the y coordinate change the sign. It was y earlier, now it is negative y. So that means this point is x does not change, y changed to negative y. So that's how you can find the values on the fourth quadrant. So the values on the second quadrant. What about the values on the third quadrant? In the third quadrant, what will happen is going to jump reflect across the origin. So that means both going to change the sign. So the x going to change the sign to the negative x, and then y is going to change the sign to the negative y. So that's how you can find the values on the third quadrant, and you can see that you only need to know the values on the first quadrant, and everything else you can find switching the sign of either x or y or both, depending on what quadrant we have. So if you use an example, for example, let's say what is the reflection of pi over 3. So that means if you reflect across the y-axis, so you can see that this point is simply going to be x coordinate change to a positive 1/2 to a negative 1/2, and the y coordinate do not change. And then if you reflect across the x-axis, what's going to happen is it's going to jump to this point down there, and then x coordinate do not change, y coordinate change to negative of that value. So that means a negative square root 3 over 2. And then if you reflect across the origin, it's going to jump to the point on the other side. So that means the point is right here. It's going to be negative 1/2 and then negative square root 3 over 2. So that means once you know the point, you're going to find the point on the corresponding point on the first quadrant, and then you're going to find the coordinate depending on that. So that's the first thing that we need to know. So the next one, we're going to talk about how to so how you can get those 6 trigonometric ratios. We know on the unit circle the radius is equals to 1. So the radius is equals to 1. So if the radius is equal to 1, dividing by 1 does not change anything. That means we can ignore that. So because of that, what's going to happen is we're going to get something easy. For example, sine. Sine is sine theta, which is the y coordinate divided by r. But since r equal to 1, it is just the y coordinate. And then if you take the reciprocal of that, the cosecant theta is simply going to be 1 over y. And then similarly for cosine theta is the x coordinate over 1, so which is just the x coordinate, and the reciprocal of that, which is secant theta, which is 1 over x. And then for tangent, you can see that tangent is simply y coordinate over x coordinate, and the cotangent theta equals to x coordinate over y coordinate if it exists, because sometimes what happen, you need to avoid dividing by 0. So this is how you can find all those ratios just using the x and y coordinate. So now let's see a couple of examples. These are all the values that can be found using the reflection argument that we discussed earlier. So let's look at some of the problems. So as the first example, let's look at how to find the exact value of cosine 150. So once you get the angle, and we first need to identify where this angle is. So this is 150. So the angle is at this point. And then also this is the cosine. So cosine means what we need the x coordinate. So what we can do, once you get the point, we can see that this is the reflection across the y-axis of this point. That means since the reflection across the y-axis is only going to change the x coordinates, so that means this is going to be negative square root 3 over 2 1/2. But we are looking for the cosine value. Cosine value means the x coordinate. So that means this is going to be negative square root 3 over 2. So that is the exact value of the cosine 150. So let's look at the next problem. So as the next problem, we have tan 315. So we need to first identify where this angle is. So 315 is the angle is with the standard position. So that is the angle we are talking about. That means this is the point we need. And we know that that point is the reflection of this point across the x-axis. So if you reflect across the x-axis, what's going to happen? X coordinate do not change. The y coordinate change the sign. Now tan. So tan means we know that which is the y coordinate over x coordinate. So we can write the two coordinate now. So which is negative square root 2 over 2 and positive square root 2 over 2. Since the two values are the same, you're going to get negative 1. So that is the exact value of the tan 315. Let's look at the next. We have sine 4 pi over 3. Sine 4 pi over 3. So first we can identify the angle. So this is 4 pi over 3. So the easy way to identify this one is, you can see that we have pi over 3 here. That means it has to be corresponding to pi over 3 there. So that means it's a reflection. That means the angle is over here, because that's corresponding to pi over 3 on the other side. So that's the angle here. So that's another way to find it quickly. And then what we can do, we can reflect across the origin. When you reflect across the origin, both going to change the sign. That means this is going to be negative 1/2 and then square root 3 and then also negative square root 3 over 2. Negative square root 3 over 2. We are looking for the sign. So sign means just the y value, so the y coordinate, and then we know the y coordinate is negative square root 3 over 2. So that is the exact value of sine 4 pi over 3. The next, we're going to cosine negative 300. So it's a negative value. That means it's going to go clockwise. Negative 300 means so it is 30 less than 360. So that means the angle going to go stop at 60. So that is the negative 300 angle. And then this is the cosine value. That means we just need the x coordinate. And since it's in the first quadrant, we already know the x coordinate, so this has to be 1/2, positive 1/2. So let's look at the next problem. We have cotangent negative 5 pi over 6. This again is a negative value, so that means it's going to go clockwise direction. And 5 pi over 6, So it's a 5 pi over 6. So that means the angle is in the third quadrant. So the angle is this one. Uh, it's also related to pi over 6. Um, so you can see, so that's the angle. So this is negative 5 pi over 6. So I'm going to reflect the across the origin. That means both change the sign. So it's going to be negative square root 3 over 2 and then negative 1/2. So we are looking for the cotangent. So the cotangent means it is the x value over y value, x value over y value. So again, we're going to substitute both values, which is negative. X value is negative square root 3 over 2. The y value is negative 1/2. And you can see that 2 and 2 get cancelled. Negative, negative get cancelled. So you end up getting positive square root 3 as the final answer. So let's look at the next one. We have cosine 270. Cosine 270, so 270 is one of the common values, so that's the angle we are talking about. So we need the cosine. So the cosine means the x-coordinate, and this is one of the terminal angle, what we normally call quadrantal angle. So we know the point is we already have is 0, -1, and we are looking for the x-coordinate. So the x-coordinate is 0. So cosine 270 is 0. And then let's go to the next one, secant 570. So when you have 570, so how much 570? 570 means, so we need to do a simple calculation. 570 means 360 plus 180 plus, and you can see that if you do that, you're gonna get 540. This is one of the common value, but you need 30 more. So that means your angle, so we can draw this. So we start with 0. So you're gonna go 360, one more 180, and we got 30 more. So that means that is the angle 570 is right here. So to what we need to do is that's gonna corresponds to 30 degrees on the other side. So that means we need to reflect across the origin. So both gonna change the sign. So it is negative square root 3 over 2. Negative 1/2. Actually, when you do a problem, you really don't need both, because if you figure out what we really need, and you can see that we need the this is a secant, that means 1 over the x coordinate. So that means we only need the x coordinate here. So and then we're gonna do the reflection is 1 over, so that's the x coordinate, but we're gonna do 1 over that. So that means since so you can do it two different ways. Since it is 1 over and it's a fraction, you can write upside down. So that means you can write the answer as negative 2 over square root 3 because it's a fraction and it's 1 over. You can write it like that, or you can just do the division. You can write it 1 divided by negative square root 3 over 2. We can write it like that, and the negative sign comes in front, and then we're going to multiply both sides by 2, so you're going to get 2 square root 3. So this is the other way to do the calculation. Okay, so and then let's do next one. So the h, so we have cosecant negative of 5 pi over 4. So the cosecant means you know that it is the 1 over the y value. So that means we only need the y coordinate. So first we need to figure out where this angle is, and you can see there's a negative angle, and 5 pi over 4 means is past the pi, so it's going to be in the second quadrant. So it's going to start here and then go end up this. So that is the angle we are talking about. So this is negative 5 pi over 4. Again, so you can see that there's a reflection of this point across the y-axis. So it's only gonna change the it does not change the y coordinate. It's only change the x coordinate. That means so the answer is simply because x coordinate, we only need the x coordinate. We only need the y coordinate. So the y coordinate is so I'm not gonna write the x coordinate now because we don't need that. So it is the y coordinate, square root 2 over 2. So that means 1 over, so it's 1 over square root 2 over 2 means 2 over square root 2. If you simplify, you end up getting square root 2 as the answer. So we can see that we did not find the x coordinate because we don't need that. We only need the y coordinate. So let's do the next problem. So we have cosine. This is a cosine. That means we only need the x coordinate of the point. So we first need to figure out where this angle is. So first we can see that this is 3. So that means if we double it, 6. So that means if you go 6, it's going to complete one cycle. So that means we have 6, one cycle, and then 12, another cycle, 18, third cycle, 24, fourth cycle. So you go 4 cycle and go extra pi over 3. So that means you can draw this angle. So we have 6, and then 12, and then 18, and then 24, and then we go extra pi over 3. So that means that's the corresponding point, and we are looking for the cosine value, which is the x coordinate, so it has to be 1/2. So that's how we can find this value. And then let's do the last one, j, which is a sine negative 240. So again, it's a negative, that means it's going to go clockwise. 240. So you can see that 240 is, we have 180 and extra 60. So that is negative 240. This is negative 240. And then we are looking for the sine. That means the y coordinate. And then what gonna happen is this is corresponding to this point, and the y coordinate does not change. That means the answer is simply square root 3 over 2. So that's how you can find those values. So in summary, we have these. So that means what we gonna do is we gonna compare with the values at the first quadrant. So relation is, we know that if it is a cosine, it is the x coordinate. If it is a sine, it is the y coordinate. If it is the tangent, it is the y coordinate or x coordinate. And if we have all those are reciprocal, for example, if we have cosecant x, cosecant theta, we have 1 over y. Secant theta, we have 1 over x, and then cotangent theta, we have x over y. So we just use the x and y coordinate to find all those values. So now you can do these as practice problems. So try to work on these problems using the unit circle method, and you can write the answers as comments to the video. Thank you.